Hi, Algo fan. Welcome to the last session of our intermediate TypeScript Bootcamp. How are you doing today, Giorgio and Algo fan?
Good. I'm really good. I'm curious to know how the Algo fam is doing also.
Yeah, I know it, because today is our last session, and just 1 month ago, many of us want to learn how to create a smart contract on Algorand using TypeScript, and today we are here finishing the intermediate bootcamp and with all the knowledge to create our own project. The challenge is to understand all the things that you explained to us, Giorgio, during this bootcamp, because we use many native features that Algorand offers to us, and we may need it when we plan to deploy our solution on mainnet. I have a lot of fun during these 2 months because we start our bootcamps on April, and right now we are finishing this first batch. And before we start with the content that Giorgio has prepared for us, I have one question for you. What could be the next step after this bootcamp to keep learning about Algorand?
So I think participating in the hackathon, in a hackathon is a vibrant ecosystem of people building, so that may be a good way to keep learning. And what else? What could also be a good way? Well, we have the Algorand Developer YouTube channel, so that is rich of content. And I think just getting started may be the most useful thing that you can do, because you can only learn so much by watching, and at some point you really need to exercise your knowledge. And so I think once you know how to dig for information by yourself, that will be the moment that your learning really accelerates. We are here to get the process started, but everything is open source and everything is, you can dig into the code directly. So that is my preferred way to learn, to dig into the code.
Oh, sorry, I was on mute. Alexander Code, he has an amazing content. So Gabor, thanks for sharing that on the chat. And I always mention the same. For me, the best way to keep learning is try to create your own solutions. So for example, after the Python bootcamp, I say, okay, I want to create my project using Python, Arduino, AlgoKit, and Flask. And I already know the things that I need to use, but I don't know how to use it. So I start doing my own testing, my own smart contract, interacting with the client. And at the end, I say, okay, I can do it. I can keep building my own products. And I hope for we are developers that I can deploy my basic solution on mainnet. So those are just basic examples, but in that way, I keep learning a lot. Okay, what else?
We have before we start, we have a question from Joel. Or do you have something planned before we jump into the content?
Just 2 announcements. Okay, 3. At the end of today's session, I will share the link so you can claim the certificate of completion. And this is a verifiable credential that you can add to your LinkedIn profile. Today is the day where you can share the certificates on your social and tag us. That help us a lot to bring more people visibility. And I will share a link so you can help us with the feedback. For us, it's important to improve the content, the way that we deliver the bootcamp. So I really appreciate it if you can help us filling out the survey. And you still have time to participate in the global hackathon, or maybe you keep learning and you can participate in the second one. So those are the things that I want to mention. So you can answer the question, George.
Okay, thank you, Camilo. So Joel, the way that you need to fix this error is because I think maybe I mentioned this in the beginner, in the Python bootcamp, and I didn't mention in the TypeScript bootcamp, but there are many ways to create an application. Some are bare by default, bare application calls. Some are API method invocations. And the way that you need to the way that you fix that type error is to have digital marketplace client dot create, and that will give you all the calls that are used to create a contract. And in the case of TypeScript, instead of being a bare call, it's a method call called create application with, and you will have to put an empty object because it takes no arguments. So this is the only actual difference that you will have to fix when you copy the front end from Python, from a Python based project to a TypeScript based project.
And maybe that is something that you already have it in the repository, that part to fix that.
Yes.
So yeah, you can
Right.
take a look, Joel, of the repository, and over there you can see the small difference. Because that is the thing, no? Almost everything can work between Python and TypeScript, but there are some small things that you need to have in mind. But yeah, so we're ready. Thanks so much for joining us, Giorgio, for preparing this amazing content. And over to you so we can keep learning how to improve our front end and then how to add more functionalities to our smart contract. Yeah.
Yes. So what we have planned for today, and we will be actually a little bit pressed for time, but we need to watch the last recording for the front end, and then we will either build live the auction features of the project, or we will review it together as an already made feature. Either or. We will see how we're doing on time after the recording. So I think without further ado, let's jump into the recording.
Okay, welcome back. In this recording, we're going to write the by method. So let's review where we're at. I think up to listings, everything should be fine. Oh, let's review if we set the stale time. Oh, we did. Okay. Well, I don't completely understand why this didn't kick in and update the listings on its own, and we had to refresh the page. That should happen on its own. If you want to get more into the details of how Unstuck query works, I know that, like for example, listing query, it has something like invalidate or refetch. Yeah, so you can like give it commands and you can invalidate the data and trigger another refresh of the data. We're not going to get into that, but just know that it should be possible to manually re-trigger catching new data in methods like selling or buying, because that's what's going to change the content of that data on chain. But anyway, we don't need the address for this. That's good. And this is the buy form, and we're gonna want more things than this. So this is a text. Oh no, this is an input box, but it's in read-only mode. And oh yeah, this is pulling from the price of the sale. This is going to have to be a normal input box because we have multiple sales now. So active address and app ID, but this doesn't make sense anymore. Units left. It's going to be up to the user to select which listing they want to buy from, and therefore I think we don't need the asset ID. Set unitary price. I think we want selling price, and maybe so then maybe this can be buying price. Buying price. Yeah, also modify the set attribute. Quantity, let's say buying quantity. Yep. Units left. Okay, this was used differently. I think we don't need this anymore because buying quantity. So let's review. We need at least the key, the minimum amount of fields that we need to determine what cell we are buying from is the seller. So we have a seller actually, but I think it's used differently in this context, but let's just recycle that state. And so we have a seller, set seller. The nonce, we are always going to have that to 0. This string I think can be empty string. So the seller and the asset ID at the very least, right? So buying asset ID and set buying asset ID. This is equal to a use state big int 0n. So the seller, the nonce equal to 0, and the buying asset, they uniquely determine a cell, and we want to say how much of that we want to buy and at what price. Units left, it's not something that we need anymore. I'm going to check my notes quickly if I'm perhaps seller address and this is my buying nonce, buying price by quantity. Yeah, no, we should be good to go. Okay, so let's review listings. We're good up to that. And so now we want, this is price per unit. So let's approach the problem this way. Let's copy a label plus a form. And so this is going to be the seller address. Maybe let's also change this to be seller address. Where were we? Okay, yeah, seller address. The value is the seller address. We don't need the toString method because this is already a string. Set seller address, and that's just the content of the field. Okay. Then the nonce is always going to be 0, and the asset ID. So asset to buy. And this is the buying asset ID. ToString set buying asset ID. This can stay the same because it's a big int. And then we have the buying quantity and the buying price. Okay. Amount, I think it's clear from the context that this is the buy form. So this is the buying quantity. Set buying quantity. And this is the price. buying price technically, but I don't think that we need to show that on the UI. Set buying price. Perfect. Desired quantity, all of this can be eliminated. Okay, so now we have to change the buy method. In this button, let's see, let's review what this button is doing. Buying quantity, yes. For buying quantity units, for buying price times buying quantity. Oh, I see. So this is displaying the, yeah, this should be correct. Yeah. Well, let's just use it and then review if this needs some fixing. I think I'm going to comment out this code. And so let's first check what the buy method is doing. Comment this temporarily. Okay. Set units left, we're not going to need this. And the sender, okay, the up address, we'll see if we need this actually. The quantity in the unitary price, okay, let's first review. So the buy method needs to an owner, an asset, and a nonce at the very least. So the owner, asset, and a nonce. Now the nonce, we said it's always going to be 0, so might as well put that here. And the owner and the asset. The sender, I think the sender should be called the buyer, but anyway, let's import this. This should be called buyer. The asset, that's important, so the asset, it's big int. What else do we need? The buy, the pay transaction, and the quantity. Okay, so the quantity and the unitary price should be enough to determine. I'm not sure why we need the up address. Transactions, payment, receiver, the up address. I don't think that, I think we should change that, right? Because the payment is supposed to go directly to the owner of the sale. Yes, exactly. So in the pay transaction, the profit in algos is going directly to the owner of the sale. So I don't think that we need to have the up address, and the receiver should be the owner. Now we are importing the quantity and the unitary price. I think we want to correct this to be quantity and unitary price. This has to be scaled back by the amount of asset decimals, which is going to be 3 in our case. So this is that begin to number. This, if I'm not mistaken, this should be 1 times 10 to the 30, so this should be 1,000. And okay, sure. Microalgos, yeah, that sounds right to me. Extra fee, yes, for the inner asset transfer. Yeah. And then the buyer transaction. All right, because this is the buy pay. Well, we can actually rename this one to be buy pay. And the quantity is this. Okay, I think this should work. State, get asset information. Oh, because this is done because the sets unit left. We don't need this anymore because we are handling the state with a 10 stack query. Let me check my notes if I'm forgetting perhaps to do something. I don't think so. Okay. Now we want to correct the call to this method, and so we know that we don't need the application and the set units. Buying quantity, buy price, that's fine. Quantity and price, but we need the owner, the asset, and the buyer. So this is the buyer, and the seller address is the owner. Okay, and we don't have a nonce, but we have a buying asset ID. No, hold on. Owner, the asset, and the buyer. Owner, asset, and buyer. Quantity and price. Quantity and price. Perfect. I think this should work. Let's test that hypothesis. Go to the code application view. Keep this console open for the moment. And we want to go to the app ID. Also, you see, it does update everything if we change the app ID, but it doesn't if we sell or buy something. So this seller address, we're going to copy this from this page. That doesn't look right. This is strange. I'm going to review like what's on how the form is defined. I'll pause the recording. I got the error. I just needed to define this type of the input as a text and not as a number. So we should be good to go. Let's switch to the application view, and yeah, we can just paste the address of the seller. Cool. Asset to buy, there's only one listing at the moment, so the asset ID, the amount. I think let's buy half of a unit, and the price is 2 million microalgos. That doesn't look right. Hold on. For 100 algos. Let's review what we have in the code. So this is the buying price times the buying quantity. Does this need to be wrapped in a big integer? I don't think so. Yeah. And oh, so this is 10 times 10 to the 6. Perhaps this is where the error is coming from. By in quantity. So by in quantity, let's let me try and create a view where we can see both the code and the application at the same time, because going back and forth is going to be a bit painful now that we have to do some debugging. Okay, let's see if this works. Yeah, I think you should be able to see both the code and the application at this moment. So let me try and program like this. So we have in this button the buying quantity, and this is correct. Like if I change the quantity, it changes in the button for 100 algos. Now we want to have a price in algos, right? So this is 1,000 algos. Could it be that? So we did another scaling somewhere else, right? But this is in the method. We didn't call the method yet, so we should be good. So we are off by a factor of 1,000 because I'm trying to buy half of something that is worth 2 algos a unit. So half of that should be 1 algo a unit. So I think that we are multiplying a buying price that is expressed in microalgos times a buying quantity that is expressed in thousands of an ASA, thousands of a unit of that ASA, right? So perhaps we should correct for both. Yeah, that looks right. So let's do some experiment and see if what happens if we buy a whole unit. A whole unit is that. So 2 algos, yeah, that looks right. And a unit and a half, maybe 3 algos. I think yeah, we need to correct. The scaling factor needs to correct for both the fact that the buying quantity is expressed with 3 decimal digits and the buying price is expressed with 6 decimal digits. So all in all, it needs to be corrected by 9 decimal digits. And the only thing is, what if we try to buy something that would result in less than a single algo? I think this is going to display 0. So that if we have 2, I think if we try to buy, yeah, 100 of, so 1.0, essentially 1.0 of an asset at this price is going to display a price of 0 algos. I really would like to have like 0 dot something something to the algos. So let me pause the recording and try to figure that out. Okay, yeah, what we want to do is actually not do the division with integers. We want to convert the not scaled number to an actual number, which can be represented as a floating point, and then divide by the scaling factor. But this will still be a floating point number, which allows us to show that that the total amount in algos is 0.3. Now, don't don't go around and think that this is 100% solid. I'm sure that there are hidden and edge cases that could break this formula down. Handling prices is a very delicate operation. but this should get you for sure in the right ballpark. So again, we want to try and buy 1.5 units of that algo, which is 3 algos in total. Before we hit the button, let's review if we are doing the same thing here. So we want to have a number of micro algos, but this does not need to be scaled by both scaling factors because we do want an amount in micro algos. So I think this is correct. And perhaps, yeah, this should work actually. Okay, let's do it. Did it work? Let's try and refresh the page and the app ID. Yeah, it worked because now the listing says that there is a new amount of assets. And let me pause the recording and see if we can validate that we have some assets in our account. Yeah, so oh, I'm sorry, I pushed the wrong button. So we are on the page in that flow of the account that we're using as a seller, both as a seller and a buyer. And for asset 1007, we can correctly see that 1.6 of that asset is still stored in the contract in a listing, and we had 10. We created 10, so that's what the leftover is on our account, so we can see that we correctly bought from the contract. Okay, that I think that concludes the. Let me switch to the code view. Okay. Right. Okay. So the only maybe problem with this at the moment is that we have used the same account. We are still connected to the same wallet, so we use the seller is equal to the buyer, and ideally we would want to also try in the UI two different accounts for the buyer and the seller. Although, in all honesty, I don't think that we would have a problem with that, since if we review the test that we wrote for the contract, we already have a buyer as a separate account from the creator. So I don't expect this to be a problem in the UI if it's not a problem in testing. So perhaps this can be homework for you to try and log in with a different account, a buyer account, and try and buy something from a listing made with another seller. And actually, now that I'm saying this, okay, we need to add something to this buy method, because the problem is that since we are using the same account, the creator is going to be already opted into the asset, because it is the creator of the asset, so by definition it is already opted in. But in general, any other account, it's not guaranteed that it is already opted in. So I think we want to have the buyer sign something to opt in that asset that he's trying to buy, so that when you make that two distinct and separate account, this should still work in the UI. So await algorand send asset opt-in, and this should be done from the buyer perspective. Asset ID is the asset. Perfect. And if you are already opted in, this is essentially a no operation, because it moves at zero amount. So if you are already opted in, this transaction essentially does nothing. So you can use the same code for both accounts that are already opted in and not yet opted in, because the transaction is essentially a zero amount asset transfer from yourself to yourself. So that wouldn't cause any problem for people that have already that asset as one of the assets that they have opted into. Okay, let's do a final review. We don't need the contract or the tests. Oh, yeah. So the last thing as a homework is doing kind of the same thing and like trying to resume this method, this delete app method, and this form, so that the seller can call the method on the contract that sends back any leftover the buy, no, that's not it. The withdraw method on the contract, which sends back the algos used as a rent for the box and any leftover asset that went unsold. And with that, I think we can conclude this session. Yeah, here. And please let us know if you have any question.
Okay, we have finished watching the front-end videos, and now, since we have not the full session available, I think instead of writing live the code for the auction and in the contract and the front end for the auction, I think we should write together the code for the contract, because that is what we are here for. We already have the contract for the front end ready, so we'll just plug it in. And this will allow us to save some time and still review the final application. And all of this will be essentially published in the repository after today's session. So I think that's what we should do. Camilo, does that sound like a good plan to you?
Absolutely. The most important part is the smart contract.
Yes, because this is also what I can teach you more effectively, because the front end, I can build a front end, but it's not going to be the perfect front end. Okay, I just need to check one thing before I share my screen, and I'm going to do that in a second. Okay, yes, I'm ready. I know I need to increase the font size. Okay. So okay, we are here to build an auction, and the purpose of this auction, if you think about it, there is a missed opportunity for buyers to place bids. Let's say that an asset is selling for 2 algos each unit, and what they are willing to pay is 1.8 algos each unit. They have to be online, in a sense, if they are waiting for the possibility of the seller to change the price of that sale. So auction is a mechanism that we will use to allow buyers to place a bid, such that the seller can accept that bid autonomously. So the buyer does not need to be online, and it can still, make an offer. So the way that we are going to do this, and there are multiple ways of doing this, will be by memorizing in the cell, in the listing, the highest bidder. And this has some advantages and disadvantages. It's easier to code than other solutions, but it can create race conditions. We will talk about race conditions in a second, but the alternative would be to save the best bid for each bidder in a separate box. And that would create less race conditions, but it would be harder to orchestrate a single auction. What I mean by race conditions? I mean that you can imagine how people on the network start outbidding each other at a high frequency. And therefore, since there is some inherent delay between when you create a transaction and when the network approves it, this is normal to any distributed system. It may be the case that some other person changes the bid before you. And this will have implications that we will see in a second. But essentially, well, no, I'm going to talk about it now, actually. So we are going to, for each bid, since we said that we want to have the seller to accept a bid autonomously, this means that the buyer will need to deposit the algos for the bid into the contract itself. Therefore, when a bid is outbidded, so some other buyer places a better bid, well, the original bidder will need to be refunded, and the new bid will need to take its place. So this means that if I have a transaction and I am bidder A creates a better bid, and the previous bidder was bidder B, it means that we need to include bidder B in the transaction for the new bid. However, if some other bidder C replaces itself in the contract before us, then our transaction will reach the application with bidder C in the contract, while we expected to have the previous bidder equal to B. This is what I mean by race condition. This is not immediately apparent now that we are writing the contract, but I'm just talking in general terms of the drawbacks of each approach. But again, instead of memorizing bids in separate boxes, one for each buyer, we will memorize the bid in the box for the listing. So we need to add some information into the box, and that is the bidder. We will not call it the highest bidder or the latest bidder, but this is what this is, and this is an address. Then we will need a bid quantity, which is a number, and a bid unitary price, which is also a number. And sure. Okay, I'm in the front-end project, so okay, so these are the new information for our auction. And now that we have increased the size of a box, we will need to modify this formula to account for the increased size. So now the key stays the same, but the value is now composed of the previous integers plus an address plus 2 numbers. So this means that in our formula, we now have 8 plus 8 plus 32 plus 8 plus 8, 64. The total is 112. So we need to modify this here too. We have a new cost for the box. And now there will be a couple of implications to what we're doing in the code that we already have. I think we will get some errors, for example, here. Yes, exactly. So this means that we only had 2 fields previously, and now when we are trying to write the content of the box, we need to also overwrite, not overwrite, but also rewrite a second time the previous fields of the box that we want to keep. In this case, these are new fields. So I think we are good to say that the builder doesn't exist yet because this is the first deposit, and this is global's 0 address. Now, 0 address is a special kind of address that is kind of supposed to be the empty address. So you know this is not a real address, this is just a representation for an empty address. So whenever we see a 0 address, we know that there is a field that is not set yet. As for the bit quantity, what did we say first? Bit quantity, yes, bit quantity, this should be 0. And the same goes for the bit unitary price, this should be 0 because there is no bit yet. Whenever we see an error, we try to fix it. Okay, now we are in the deposit method. And now it is like possible that we already have a bid set. So what we should do is we should kind of extract every other field too from this box. So let's say current bidder, and this is equal to this box dot bidder. And we obviously want to fix the code because this is already going over my screen. Okay. Then we have a const, we have a current bid quantity, which is equal to bid quantity, and current bid unitary price. Bid unitary price. And the only thing that we need to do at this point, because we know that a deposit only changes the amount of things deposited, every other field we can just write it as it was before. So this is the bidder, will be equal to the current bidder, and like same for the other fields. Okay. Now price, setting a price, this also, the only field that changes is the unitary price. So I'm pretty sure that we can just take these fields that we extract from the box and extract them to here. Only that we have an asset and not an asset transfer. And we need to set them here too. So just copy. As for the buy, so in the buy transaction, the bid shouldn't change. So we're probably good to also extract the fields from the box. And I want to do it. Let's do it from here, but we will need to change who the owner is. Careful, you need to say that the owner of the box is not the caller, because the buy method is called by the buyer, which is in general different from the seller. So that's why we specify a different owner. And you need to modify this information in the box, because otherwise we are fetching the right box and the wrong box for some of the fields. So this is really important. Now in the buy, these are staying the same. So now I want you to notice something about this code. The thing that we need to understand is that when someone buys at the current price for that list, we decrease the quantity, right? Because we are saying deposited minus the previous deposit amount minus the quantity that was bought. This means that it is possible for a listing deposit to go under the bid quantity. So a bid could happen before a buy, which means that when the buy is over, the buy operation is over, the bidder wants more than what's available in the contract. Right now, we only need to notice this. It will come into play later when we're writing the accept bid method. Okay, so I think we want to write the bid method now. We will need to identify the box, and in general, we said that the buyer is different than the seller. So we will need to specify the owner too. Okay, so in order to accept a bid, we said that the bidder must deposit the algos into the contract. So let's accept a bid pay, a quantity. So this would be the quantity that the bidder wants to buy, and a unitary price. This is also the price for the bid, not the price for the listing. Okay. So just as a sanity check, we don't want a bidder to place a bid if they are not opted into the asset. This is not an unnecessary condition for this method, but by checking this as early as possible, we prevent problems further down the road. And of course, they are always free. The bidder is always free to close out of the asset while they have a bid open. However, it's nice to check, and it can prevent some of the problem earlier rather than later. And yes, we want to extract the information of the listing for two reasons. We only want to accept bids that are for an amount that's less or equal to the current deposited. So let's extract that information from the box. I mean, I'm thinking that I want to keep a copy of this box. Deposited, and we want to do the same for the current unitary price. And again, we want to assert that the quantity that the bidder wants to buy is less than or equal to, actually, than the current deposited quantity. The price we will need in a second, because it is how we determine the highest bidder. So in general, the highest bidder will be the one that pays the most. So this could also mean, in theory, that a higher bid for a smaller quantity is considered the highest bid. The implications of that depend on, kind of what you wish to do with the new bid. You may wish to also say that that the unitary price. Wait, I think I'm getting confused. Sorry, this is in relation to the listing. The current unitary price is in relation to other bids, not in relation to the listing. So I'm getting ahead of myself. Let me just write the code and we'll talk about it. So we want to say that the current bidder So if we know that if the current bidder is different than the zero address, then we know that a bid is correctly set. And if we already have a bid, it means that we need to check if this bid is better than the one that was before it. So let's extract the current bid quantity and the bid unitary price. And we want to assert that this is a better bid than the previous one. So we want to assert that the unitary price is strictly more than the current bid unitary price. Okay, so this is the place where I was kind of getting ahead of myself. If you want, you could also say something like the quantity, the new quantity, the new bid quantity must be more than or equal to the current bid quantity. Because you can easily imagine how someone will outbid you with a slightly higher price, but the quantity is very small. So depending on what the seller and what the marketplace wants to provide, they may choose to also check if the quantity stays the same. But this is really a matter of preference rather than safety for the auction. The important thing is that the new price is higher than the current one. So we want to now compute, now we are setting the box such that we can write the new bid. And in order for us to do that, there is one last thing that we need to do. We need to refund the previous bidder. So let's do that. Bid deposit. This is a variable representing the amount of algos that are stored in the contract. It is nothing new. We already did something like this. Current bid unitary price, current bid quantity, and we, as always, we correct for the asset decimals. And we send the payment to the current bidder for an amount equal to current bid deposit. And that's about it. So now we have, checked the conditions of the new bid against the old bid. Now we are free to overwrite the new bid on top of the previous one. So the new bid deposit is the unitary price times the quantity, again corrected for the asset decimals. And we want to verify that the bid pay that we are accepting, the sender is equal to the caller of the method, the receiver is equal to the application address, and the amount is what we just, bid deposit, what we just computed. So now we have verified that the bidder actually sent the money to the contract. So now we're free to update the value of the box. Okay, we still have the value. Deposited, this shouldn't change, so it's the current deposited. Unitary price, this does not change. However, the new bidder is the caller of the method. The bid quantity is equal to the quantity as an argument, and the bid unitary price is equal to the unitary price. I wasn't expecting this error. Is it possible that this is I see where I made my mistake. I mistakenly wrote to the box the bid price for the listing. This, of course, will be a huge error because we would allow a bidder to change the price of the listing, which, of course, it's an attack, and we don't want to do that. So this is the current unitary price. Okay. So now we need a way to accept bids. And this is only callable by the only bids that you can accept are bids related to your own listings. So we don't need to specify a new owner because it will be the caller. This is an asset ID and unknowns. Okay, so let me bring in some code just because we have seen it a bunch of times now and we don't need to write it from scratch every time. These are just all the fields in the box and I have just extracted them into variables. So in order to accept a bid, there must be a bid present. So we want to assert that the current bidder is different than the 0 address. And if this is true, we will know that there is a bid present. Okay, so now comes into play that thing that we talked about, which is the bid quantity could be potentially higher than the deposited amount. So we will need to account for that, and we will declare a mean quantity, which is equal to, this will need to be the minimum between the bid quantity and the current deposited. So using the ternary operator, we will say that the current deposited, current bid quantity. So if this is true, then the minimum value is the current deposited. Otherwise, is the current bid quantity. And we want to send an asset transfer okay, the asset amount is the mean quantity. Okay, so again, it doesn't really matter if we move the money first or the assets. At the end of the day, this is a transaction. So it will either succeed in its entirety or it will have no effect. So we can just send the assets first and then move the money to the seller. Now we're just computing how much algos are deposited, and again we always compute this in this contract by multiplying the desired price times the quantity and scale it by the decimal digits of the asset. So we want the current bid quantity, and we want to scale it back by 10, again, 10 to the asset decimals. Now we send the money to the seller. The receive, made a mistake. The receiver is the color of this transaction, the color of this method, because in the accept the bid, it will be the seller. And the amount is the current bid deposit. Let me check something. So when we place a bid, I may have forgotten to do something. Hold on. Okay. So I'm just now noticing live that we haven't written a condition on the price. So I like it. It's like this condition right here. We can accept technically bids for higher prices than the listing price. It's not an error, but I'm not sure why a bidder would place such a bid. So I don't think that it matters to us. And so keep in mind that we are not checking the price of the bid against the price of the listing. Even though, and another reason for not checking it is that it's responsibility, of course, of the bidder to place a lower price than the listing price. But remember, we can also set the price manually of a listing, which means that just as the buy method can lower the deposited amount, we can lower the price for the listing. And so potentially there could be bids with price higher than the listing price. This is not a mistake, this is an error. Yeah, so I was just wondering why we were missing a check on the bid price against the listing price, but it's fine to do so. Okay, so again, back to us. We are writing the accept bid. We have verified that it's set. We have computed the minimum quantity between the two. And now we have sent the assets to the bidder and we have sent the money to the seller. So what it remains to do is to lower the bid amount and the deposit amount. Deposited, this is equal to the current deposited minus the min quantity. The unitary price stays the same. The bidder can stay the same. It's up to you if you want to choose to remove the bid, even if it's not closed out in its entirety, because either the deposits are zero or the bid is zero. It's up to you if you want to close it. I decided not to close it, but it would be fine if you decide that you want to close it and set this field to 0 address. Now the bid quantity is the current bid quantity minus the min quantity, which is what we traded. And the unitary price stays the same. Perfect. So yeah, so with these two new methods and the new box structure, we can place bids and accept them. Keep in mind that another race condition that might happen is that I'm sending an accept bid because I'm seeing a price that I like and a quantity that I like, and I send an accept bid. However, it may be possible that a bid is placed in a block earlier than my transaction. So it may be possible that I accept a different bid than what I saw initially. If you want to prevent this, you will need to place arguments in this method saying what are the parameters of the bid that you are accepting, such that when this method is executed, the contract can compare the bid that you are expecting to accept and the bid that it is actually present in the contract. And you can have tolerances on that. This can get much more complicated than this, but just keep in mind that this method will accept any bid that is currently present in the contract. Last modification that we want to make is in the withdraw method, because if you think about it, there is no way for a bidder, we didn't write any method for the bidder to retract their bid. So it sounds fair that the highest bidder, when the listing is closed and the box is deleted, they are refunded of the algos that they deposited. So again, I'm going to bring in some code that we already have that is just extracting values from the box into variables. And now we want to say that if the current bidder is different than 0 address, then we want to compute how much algos they have deposited. Current bid deposit. This is a wide ratio of current bid unitary price, current bid quantity. And refund them. And that's pretty much it, I think. So if there is a bid, then we know that some algos are deposited, we refund them, and then we delete the box. And we keep the refunding of the box alive, and I mean, we still refund the seller for the box MBR, and we refund them of any unsold assets. So I think we are actually good to try and compile this contract. Okay, perfect. So this is the contract that you will that I will upload after today's session. And as promised, I think it would be too much. We would be too pressed for time if we try to write the front end too. So let's just explore the front end as it is. So the contract is here, and we have made some. I have already made some modifications to the application, but I think before showing you the code, let's review the application. So I want to go into the front-end project, because now I want to allocate project run link, which is actually not necessary, I think. It's not run, it's just because the npm run dev will run this command on its own, but just in case. Npm run dev. Okay. So Gabor asks if transaction ID as a tool to get rid of race conditions. Yes, possibly. Why not? So this is an interesting question, and I think that there is some capabilities of a contract to check the existence of a transaction, but I'm not sure if they can inspect the content of that transaction. That I don't think that they can. And even if I think I remember that the information about the history of the chain, or I mean, to say this more correctly, a portion of the information of the history of the chain is only available to the contract if it is within 1,000 blocks of that method call. So even if we could inspect the content of that transaction, which I don't believe that we can, I'm 99% sure that we cannot, just seeing the transaction ID wouldn't tell us what kind of transaction that was. And even if we only have 1,000 blocks to do that, after that it becomes an unrecoverable situation. So something similar to the transaction ID could be used. Think about it kind of in terms of, I don't know if you're familiar with trading on an AMM, on an automated market maker. There is a concept called slippage, and that is, like, in general term, is the error on your trade that you are willing to accept. Because by the time that you send your transaction and it reaches the DeFi protocol, the pool conditions may have changed, and most likely will have changed. So the slippage is how much error you are willing to tolerate on your order. And so a similar mechanism can be implemented for this auction, like saying that I'm willing to accept this bid at this price and for this quantity up to a small error. Does that make sense? Okay. Okay, so again, we're doing a demo of the built application. We need to keep this in mind, 1019. Let's create a listing for 5.5 units at a price of €2. Okay, we can see the listing in the contract. And now, the way that I decided to do it is reusing this form. You can use it for a buy operation or for a bid operation. So we need to see who the seller is, which in this case is the account that I'm logged in as. And so the listing is, the seller is this, the asset is 1021. The amount, let's bid for 2 units at a slightly lower price, 1.8 algos. Bid. Okay. We will have to review, to refresh the page. And now at the bottom of this page, you will see the best bid for that listing. And in order to select which listing you want to see the bid for, you need to just input the information about the listing, which in this case is the seller address and the asset. So we can see that there is a bid for this listing, and it's for 2 units and a price of 1.8 algos. And we can see that already the web app is saying you can accept this bid for 3.6 algos. Let's try to do that. Oh, so hold on. No, before that, I would like to show you the actual balance changing. So the asset is 1021, right? And right now we have 4.5 units because we deposited 5.5. I want to accept this bid. And we successfully got the assets. I'm not sure there's much more to show about the demo because the buy works as before, and we're still using the same form for everything. So maybe let's review issues. So I want to close this process. And the bit that I want to review is that, so, you know, we should be familiar by now with the use query. So we write a function that takes the content of the box and also the name of the box. And this is for the listings, right? And notice that this code doesn't change because even though we added more field to the box, the previous fields are still in the same position, so we can still decode them correctly. The other function, the new function that we built is best bid query. And we can see that this query depends on the application ID, the seller address, and the buying asset ID, which means that each time we identify a new listing, this query should update. Obviously, I'm ignoring the nonce, which is always equal to 0 in this case. In a production case, the nonce may want to change. So once we have the listing identified, we get the box content for that listing, which is, again, the key is the seller address, the asset ID, and the nonce. And we extract the address the same way that we did before, knowing that the new fields are concatenated in the content of the box after the fields that we previously had. This best bid query, we are then displaying it at the bottom of the page here. Disable sticky lines, perfect. And in much the same way as we did before. So if the query did not get an error and the data is set to something that's not undefined, then we show it. And we also show the bid method called button, which in this case we did not write a new function in this file. We did not write a bid function because in this case it's really simple. There's not much that we need to do other than just calling the method on the application client. So you can see that we accept a bid by specifying the asset from the fields and the nonce equal to 0. And I think so the code will be very much similar to what we and the bid function also. We have a method called right after the buy method, and it's the same exact thing. It's so simple that I wrote it directly in the application, and we just call the bid method with a bid pay created with the algorithm client. And I mean, it's in the same style, in the same spirit as what we did so far. So I don't know, Camilo, do you think we can end the session?
For sure. I don't know if the Algo fam have any questions. This is the time to take the opportunity to ask those questions about the things that Giorgio just showed to us. And meanwhile, I want to thank you, Giorgio, because you prepared this content for this bootcamp. I know that you spend a lot of effort, but this is a very useful resource for all of us who wants to create our own project on Algorand. Sometimes I feel that there is a lot of content to process, but then I remember how useful it is, and I keep watching the videos and try to understand step by step. I already shared the link so you can claim the certificate. And hold on a second, this is something that I will share the link, the QR code. So the people that is going to watch the recording later can also claim the certificate. So one moment, please. We don't have questions. All the people is still processing all the information. So I will share this screen. So you can scan this QR code, and also on Tuesday or Monday, we're going to send a follow-up email explaining the process with the link so you can claim the certificate of completion. And if you have any issue claiming the certificate, you can send me an email. What is my email? One moment. I'm going to put that on the chat. Okay, that is my email. If you have any issue claiming the certificate, Douglas, yeah, feel free to ask the question about the issue that you are facing. Maybe it's related with the testing or something like this. I remember to saw it. I need to be honest with you. The next week, I'm going to start playing with the TypeScript Bootcamp. So maybe the next week I can give you a hand, but if you want to ask the question right now, feel free to do it. My friend, how do you feel during this bootcamp? Do you enjoy this experience?
Yes, of course, and of course I thank you for your compliments, but I enjoy it preparing the material, and delivering it is also a huge honor for me because I feel like it's really important that we have an easy path to understand the material. So I have really enjoyed it. And the people attending, I feel really good about the the questions that we had, and the chat that we had, and I feel like it was a very productive bootcamp.
Wonderful.
Okay, so Douglas.
And also, yeah, go ahead.
Yeah. So I have a question from Gabor too. So the question is: contract-to-contract communication methods. Only log can be used for getting the result of a contract called from a contract. Right. So yes. In general, yes. With some caveat. When you make a contract to contract, it means that you are making an inner transaction call from an application call. You're making an inner application call, and the log is the only method to pass information. However, in the case where you have, but this is hard to execute. In the case where you have a group transaction with subsequent application calls, so not nested but listed, then it is possible for one application to read the scratch state of a previous application call. And that is, again, a method that I've not seen very often. So this is maybe the only caveat that I see with contract-to-contract communication. But this is, again, only works if the application calls are in a group and not nested. Okay.
And we have the Douglas question.
Yes. In the beginner TypeScript testing video, extra fee are coded. Okay. I would like to check something in order to answer this. It's going to only take a second.
And then also invite the people that can help us to fill out the survey. So in that way we can improve based on your feedback. And don't forget that in the upcoming weeks, we are planning to upload the recording of these bootcamps to our Algodevs YouTube channel. So I just share the link on the chat. You can subscribe. And during the year, we are planning to create more and more relevant content that you can see over there.
I'm sharing the screen to answer Douglas' question. So, you're getting an error on the fee field of the send params. So if we step into, so I'm going to hold my control button and click on fee property, the fee field, because this will take me to the definition of the fee field. And we can see that the fee field must be an algo amount. So, for instance, we have functions like microalgos that return an algo amount, or we have functions like algos that also return an algo amount. What you have, if I'm not mistaken, you have algos dot microalgos. So if we review what it happens there, so algos returns an algo amount, and on top of that, we call the microalgos, which returns a number. So this is where you're getting your error, because microalgos does not return an algo amount itself; it returns a number. And again, the fee field expects an algo amount. So the way that you can fix this is if you want to express your fee in microalgos directly, you can use the function microalgos. If you want to express it in algos, it's enough to just say, so for example, this is equivalent to algos and 0.3. No, that's not true. 0.003. These two notations are perfectly equivalent, and they both return an algo amount. So this is how you can fix that.
Okay, perfect. So thank you all for this great content and education. It's fantastic. Douglas said on the chat. Gauer said, whoa, this is it. Dear Algo fan, Algo devs, in that way we end our first batch of bootcamp for this quarter. We are planning other kind of content for the rest of the year. Thank you so much, Giorgio, and to all the DevRel team. And thank you, the community, for support us, for joining us, for participate in this event. That's all. I don't know, Giorgio, if you want to give final closing words for this bootcamp.
No, just thank you, Camillo, too, for supporting the bootcamps. I know that you also have been working very, very hard for the bootcamps. So thank you.
This is a team effort, and I'm sure that all the community really like this kind of content, and they can have a useful resource to replicate the content that we just showed to them. So thank you so much, guys, and looking forward to seeing you in the upcoming bootcamps. And you can help us to engage on Discord, because sometimes we don't have enough time to answer the questions, but yeah, the Algo Devs community can support us in that way. Thank you and have a good one.